In this simple math lesson, we're going to take a look at solving compound inequalities. Let's go ahead and get started. Here's our first look at a compound inequality, which is simply two separate inequalities connected with the word and. What this means is that we must find values of x which make both inequalities true at the same time. To do this, we'll solve each inequality separately and then combine the ranges of values for x into one final solution set. Hopefully by this point you're comfortable solving a single inequality. So for each problem, I'm going to speed through the individual steps and spend more time discussing the solutions. Let's first take a look at the inequality on the left. To solve this, we'll subtract 5 from both sides and then divide by -2, which gives us x is greater than -2. Don't forget that when we divide by a negative number, we switch the direction of the sign. We'll leave this range of values alone for a minute while we solve the inequality on the right. For this inequality, we'll subtract 8 from both sides and then divide both sides by 3, which gives us x is less than or equal to 5. This time we divided by a positive number, so the direction of the sign stays the same. Now we need to combine these separate ranges of possible values for x into one solution set. To do this, I find it is easiest to look at the ranges on a number line. So let's go ahead and add a number line, and then I'll also add our numbers, -2 and 5. First, we'll look at the range on the left, written in blue. X is greater than -2. We'll draw an open circle at -2 because x can't equal -2, and then draw our arrow to the right, showing that x can take on any values greater than -2. Now let's look at the range of values on the right, written in green. X is less than or equal to 5. For this one, we'll draw a closed circle because x can equal 5, and then we'll draw an arrow to the left, showing that x can take on any value less than 5. Finally, we need to combine these two separate ranges of possible values into one solution set. Remember that because these inequalities are connected with the word and, that we need to find values of x that make both inequalities true at the same time. Well, if we look at our number line, we can easily identify those values by finding the area where the two arrows overlap. This area represents all the values of x which make both inequalities true. We'll draw our final solution set on the actual number line. Let's first start by drawing the circles. We'll draw an open circle at -2, because remember, we need to find values for x that make both inequalities true. But looking at the range of values on the left, we see that x can't equal -2. And then we'll draw a closed circle at 5, because in both ranges it is okay if x equals 5. Lastly, we'll shade in the area between these circles where the blue and green arrows overlap. Now we've got a visual representation of all the possible values of x which make both inequalities true. X can equal all of the values between -2 and 5, including 5, but excluding -2. Let's go ahead and write our solution set using inequality notation as well. We write -2 is less than x, which is less than or equal to 5. It's always a good idea to check your solution. To do that, we'll choose a few values for x both inside our solution set and also outside the solution set. We see that x equals 0 is inside the solution set, so let's go ahead and test that value first. On the left, we get 5 minus 2 times 0 is equal to 5, which is less than 9. And on the right, we get 3 times 0 plus 8 is equal to 8, which is less than 23. So x equals 0 works for both inequalities. Now let's take a look at a value that lies outside of the solution set. How about x equals 6? Well, on the left, 5 minus 2 times 6 is equal to -7, which is less than 9, so that's okay. But on the right, 3 times 6 plus 8 is equal to 26, which is not less than 23. Remember, we need values of x that satisfy both inequalities, so x equals 6 can't be included in our solution set. Feel free to try other values for x both inside and outside of the solution set, and you should get the same results. Now let's go ahead and take a look at another example. In this second problem, we once again have two inequalities, but this time they are connected with the word or. So for this problem, we only need to find values for x that make at least one of the inequalities true. Once again, we'll first solve each inequality separately. In our inequality on the left, we subtract 3 from both sides and then divide by 7 to get x is less than -6. In our inequality on the right, we subtract 7 from both sides, and then divide by 8, which gives us x is greater than 8. Now let's look at these ranges on a number line to help us get a better understanding of what's going on with the possible values of x. We'll go ahead and add in the number line, and then add our numbers as well, -6 and 8. First, let's draw x is less than -6 by drawing an open circle at -6 because x can't equal -6, and then drawing an arrow to the left. Next, we'll draw x is greater than 8 by once again drawing an open circle at 8 because x can't equal 8, and then we'll draw an arrow to the right. Okay, now let's take a look at what we've got. Unlike the last problem, there is no area where these two arrows overlap, but that's okay. When we use the word or to connect our two inequalities, we don't need values of x that satisfy both inequalities at the same time. We just need to make sure the values of x we choose satisfy at least one of the inequalities we're dealing with. Well, if x is less than -6, then the inequality on the left is satisfied. Or, if x is greater than 8, then the inequality on the right is satisfied. So we can actually use both of these ranges of values in our final solution set. To draw that final solution set for the compound inequality, we simply copy both arrows onto the number line. Now to write our solution set using inequality notation, we just write x is less than -6 or x is greater than 8. Now let's check some possible values for x like we did in the first problem. First, let's look at x equals -7. On the left, we get 7 times -7 plus 3 is equal to -46, which is less than -39. But on the right, we get 8 times -7 plus 7 is equal to -49, which is not greater than 71. But remember, these inequalities are connected with or, so we only need values of x that make at least one of the inequalities to be true. Therefore, x equals -7 is okay. Similarly, if we choose x equals 9, then on the left we get 7 times 9 plus 3 is equal to 66, which is not less than -39. But on the right, 8 times 9 plus 7 is equal to 79, which is greater than 71, so x equals 9 is okay. Finally, let's look at a value that is not in our solution set. I'll choose x equals 1. On the left, we get 7 times 1 plus 3 equals 10, which is not less than -9. On the right, we get 8 times 1 plus 7 is equal to 15, which is not greater than 71. Well, since x equals 1 doesn't satisfy either of the inequalities, it can't be included in our solution set. And once again, feel free to test out other values both inside and outside of the solution set, and you should get the same results. Well, that's all we're going to look at in this video. So hopefully now you have a basic understanding of compound inequalities. Thanks for watching this simple math lesson.